one device to the another device. Example I've written here, transferring data to printer is an example for the bug transfer. Now isochronous data transfer, this is used for real-time data communication. In isochronous transfer, the data is transmitted as streams in real time. So for example, the audio devices uses isochronous data transfer. Now here in control transfer and bulk data transfer, error checking is done, but when I say isochronous data transfer, error checking is not done. Now the devices like audio device and medical equipment, they use the isochronous data transfer. Now interrupt transfer, this is used for transferring very small amount of data. Say for example the mouse. Now what are the data that you transfer? Only a click, and the keyboard, it's only a button press, and only few amount of data is going. So that time and even the mouse is these days you have the mouse, USB mouse and the USB keyboards, all these things they make use of interrupt transfer because only small amount of data is being transferred. Yeah, and the next external communication interface is IEEE 1394 Firewire. It's again a wired isochronous high-speed serial communication. That means which does the data transfer in real time, also known as high-performance serial bus. Now it was started by Apple Inc. in the year 1985, and the standard for this was coined by IEEE. This is the standard number. Now the specification of this bus is given by IEEE in the standard 1394. This is the standard for this bus. If you Google it, you'll find the standards which governs the functioning of this particular bus. Now and implementation of it is available from various players and different. So you have IEEE 1394 bus implemented by Apple Inc. and then implemented by Sony Corporation and Textat Instrumentation. Now Apple calls it as Firewire and Sony Corporation calls it as iLink, and Texas Instrumentation calls it as Linux. Yeah, and 13149 supports peer-to-peer communication and point to multi-point communication also. Using this, one-to-one communication is also possible, and one-to-many communication is also possible, and is a wide serial interface that support cable length up to 15 feet for interconnection. And examples are the digital cameras. Now I want to connect digital camera to my PC. Now usually it will have 1314 communication interface, camcorder, scanners to desktop computers, and the printer to desktop computers. Most of the majority of the devices to the laptops and the desktop computers these days are coming with IEEE 1394 bus. Yeah, and does not require a host for communicating between the devices. So for example, you can directly connect a scanner with a printer for printing. That means you don't require a computer system. So a scanner can be directly connected to the printer for printing. And 1314 is far higher than the one supported by the data rate supported by this is much faster than a USB 2.0 interface, and but this is costlier to implement than compared to USB. Next is infrared. So this is well known. Let me not take much time to complete this because your TVs uses the infrared rays, the TV remotes. Now and again it is serial, half duplex, and line of sight based wireless technology. That means you got to point the remote to the particular device. Line of sight is that. Now if you point it in the opposite direction, it will not work. And this is being used from the olden days. I mean quite a long from the longer period of time. So remote control of your TV, DCD, all these things are based on the infrared. Now what they do, the communication technique used here is infrared waves of the magnetic spectrum for transmitting the data. They support, as I told, point to point and point to multi-point communication, and the range is from 10 centimeter maximum 1 meter. Yeah, this is the symbol, and IR supports data rate ranging from 9600 bit per second to 16 Mbps, and based on the data speed of the data transmission, IR is classified into these many types. One is SIR, that is serial IR, supports from 9600 bit per second to 115.2 kbps per second. MIR, that is medium infrared, supports data rate from 0.5 Mbps to 1.1 Mbps. FIR, fast IR, supports the data rate up to 4 Mbps. VFIR, that is very fast IR, supports up to 16 Mbps, and the ultra FIR, fast, 96 Mbps. IRDA, okay, and involves the transmitter unit for transmitting the data over IR and receiver for receiving the data. It has both. One IRDA involves both transmitter and receiver. Now, who acts as the transmitter? The light emitting diode. So, light LED acts as the transmitter, and there is a photodiode which will be acting as the receiver. But when it comes to the since it involves both transmitter and receiver, it is called as transceiver, because it can access the transmitter also and it can access the receiver also, hence it is called as transceivers. And certain devices like TV, they are only unidirectional, because the direction is only one-way communication. Now Bluetooth is once again a low cost, low power and short range wireless communication technology. So first proposed by Ericsson in the year 1994. It operates at 2. These are all the specifications which you have to remember. I cannot tell more on these things. 2.4 gigahertz, and the range is data rate is 1 Mbps to in the approximately from 30 to 100 feet. Yeah, and again there is something called as two layers here, two essential part. One is physical link part and protocol part. Physical link part is responsible for the data transmission, and the protocol part is responsible for all the communication rules which counts the say how the data should be transmitted, what is the start bit, what is the stop bit, all these things. And again, every Bluetooth device has a 48-bit unique identification number, and this is the identification number that is used for uniquely identifying the devices, Bluetooth devices. So, and point-to-point communication follows the master-slave relationship. When a network is formed with one Bluetooth device and more than one device as slaves, it is called as piconet. One device is a master and other Bluetooth devices are acting as slave, it is called as piconet. And when I say piconet, there can be a maximum of 7 slave devices, not more than that. So next is Wi-Fi. So wireless fidelity, popular wireless communication technique for networked devices, and the Wi-Fi works with the standards 802.11 standard. So this is the standard given by IEEE, and the Wi-Fi works on these standards or follows these rules for its working. And when I say Wi-Fi enabled system, Wi-Fi enabled system will have the IP addresses, and this is the one which uniquely identifies the device within the network. This is the Wi-Fi, the picture what you are seeing, and all these devices, they'll get an unique number called as an IP address. Each one has its own IP address, and that is how this Wi-Fi router device will handle all of them. This is the wireless adapter, and operates at 2.5 gigahertz or 5 gigahertz radio spectrum. So ZigBee is another low power, low cost wireless communication network. So and this ZigBee is based on IEEE 802.15 standard, and because 2006 is the year when this standard got approved by IEEE, and this is most widely used for personal area networking. And this is the operating frequency of the ZigBee, and the distance up to 100 meters, and the data rate of 20 to 250 kilobits per second. Now again, ZigBee device falls under one of the following ZigBee device category. ZigBee can be a ZC, ZigBee coordinator, ZigBee router, and ZigBee end device. Now what ZigBee coordinator can do, it can act as the route for the ZigBee network, and ZigBee router is responsible for passing the information from one device to the another, and ZigBee end device is the ultimate receiver of the data. So this is what you can see: ZigBee end device, ZigBee router, and ZigBee coordinator. So this ZigBee coordinator is coordinating two ZigBee routers, and this ZigBee router is sending data to three ZigBee end devices. So, and next is the GPRS. Is a communication technique for transmitting data over the mobile communication network like GSM, and again and the majority of you are using the GPRS. Now the maximum transfer rate is 171.2 kbps per second, and yeah, that's it. And again, this supports a point-to-point communication, point-to-point protocol, and internet protocol. This is where the IP address and all comes into picture. These things you can go through. These are all the specifications. And next is embedded firmware. So embedded firmware refers to the software or the control algorithm which is there inside the embedded system, and that is the one which is responsible for controlling the functioning of the entire embedded system. Now how do you develop this controlling algorithm or the embedded firmware? There are many IDEs available. Write a program in high-level languages like C or C++ using an integrated development environment. When I say, and Keel is an IDE, integrated development environment, because it has an editor, compiler, linker, debugger, and simulator also. You can also simulate the programs. So Keel is an IDE. And many other IDEs are also available for developing the embedded firmware or the controlling algorithm. Now here is the example, the Keel which is mentioned, Keel Microvision 3, but what we are using is Keel Microvision 4 IDE. Now using this you can go for developing the firmware for the microcontroller 8051, LPC2148, many controllers are there. And then write an assembly program in assembly language you can write, and if you want you can also write it in the high-level programming language. That is what the IDE supports. Now when you are writing an assembly level program, and if you want to transfer the same thing to the microcontroller, you got to, whether it is an assembly program or whether it is an embedded C program, it got to be converted into the X file. And in the previous classes I have shown you how to convert it into the X file. So stepper motor and DC motor program, when I explained, so there I showed you how you can convert the X file from the embedded C program, how to get the X file from the embedded C program. Now the methods used for X file creation is different depending on the different programming techniques. Now assembly language based programming technique can use a different tools, but what we are using is the Keel, and you know how to generate the X file in the key. I think I need not explain this. Now for a beginner in the embedded system software field, it is strongly recommended to use high-level language than compared to the assembly language, because writing codes in high-level language is very easy, and the language, the program written using high-level languages are also portable, and the programs written in high-level languages are not developer dependent. That means any skilled programmer can easily, when he go through the program, he can easily understand the program. But it is not the same case with the assembly program. When you're writing the program in assembly language, you require a lot of skills, and also difficult for even a skilled programmer also to understand what is being written from the assembly level programming language. So embedded software development process in assembly language is tedious and time consuming because the program length will be more, but if you write using the embedded C program, the program length is less. But the performance wise, the programs which are written using embedded C assembly level language have very good performance than compared to the programs which are written using high level programming languages. Now this is the end of the module 3. With this I have completed module 3 full. In the next class I'll be starting with the module 4. And before that, module 4, let me give 2 more lab programs. One is displaying the hello world message using the internal UART. UART, just now you understood, that is universal asynchronous and receiver. Asynchronous receiver and transmitter. So that is what we'll make use of in order to display the hello world message on the system using an internal UART of LPC2148. Another program that I'll be explaining in my next session is DAC, digital to analog converter, that is generating the square wave and the rectangular wave. Now after this I'll be starting with the module 4. Thank you guys. Please go through the video and understand the concepts. Most of the things you're familiar, and in this chapter especially the communication interfaces, you got to remember lot of specifications of onboard communication interfaces and external communication interfaces. Yeah, thank you.